I want to talk a little bit about the differences between operating in the conventional mode and how it's different from the command mode. I've got this old Lionel transformer connected to this loop of track with 2 power wires, which is about as simple as it gets. When I move the lever on the transformer, it puts voltage on the track and the train moves. You might say that I give instructions to the train to tell it what to do by communicating with the track. If I want the train to go faster, I tell it to do that by sending more voltage to the track from the transformer. If I want to stop the train, I just turn down the transformer and the train stops because there's no more voltage on the track. This is what is called the conventional mode, and it's worked fine for 100 years, but as soon as you want to run more than one train on the same track, conventional mode becomes a bit difficult to use. Here's the problem. Now I've got 2 locomotives on the same track. If I turn on the power, what happens? They both try to run because they're both getting the same instructions from the track. However, they may not run at the same speed, and there are situations like this where the locomotives may not even be set to run in the same direction. In conventional mode, you have no way of separately controlling each locomotive because they're both getting the same instructions from the track, whether you want them to or not. If I interrupt the power to change the direction of the locomotives, both units get the same instructions to cycle their reverse units to the next step. However, since this locomotive is not in sync with the other one, they still don't run together. In conventional mode, there is no way to separately control more than one train on the same track. To gain some measure of control in conventional mode, most people have built big, elaborate control panels, bristling with wires, buttons, and toggle switches. That way, they can separate their track into sections called blocks and allow them to have control over multiple trains even though they're operating in conventional mode. Wouldn't it be nice if there was a way to separately control each locomotive, no matter where it was on your layout, without all that complicated wiring and a construction of a big control panel? Well, there is a way to do that, and that's exactly what command control is all about. Let's hook up the TIU to the track and get into the command mode so I can show you. I'm going to remove the wires from the transformer and connect them to output channel 1 on the TIU like this. The red terminal should be connected to the center rail and the black terminal is connected to the outside rail. I've got another set of wires that I'll connect between the transformer and the input channel 1 on the TIU. When you connect the wires to the transformer, be sure to connect them the right way. Now on this old KW, the U terminal is the common and the A terminal is the hot. And so the U terminal is connected to the black input on the fixed in 1 connector. The A terminal is connected to the red. However, not all Lionel transformers are wired this way. The popular old 1033, for example, is exactly backwards from this. To find out how to wire your transformer, check Appendix D in the MTH DCS instruction book. You must be very sure that you connect your transformer to the TIU correctly. If you were to use both sides of a dual throttle transformer, and you happen to get one side connected correctly and the other side connected backwards, you end up with a direct short through the TIU. However, in these older transformers, the breaker may not trip fast enough to avoid damaging the TIU. So be sure you connect the transformer correctly. The list of compatible transformers is in Appendix D in the DCS instruction book. One easy way to prevent damaging the TIU is to put inline fuses between the transformer and the TIU. These fuses will blow almost instantly when there's a short, much faster than the circuit breaker in these old transformers. I now have all the wires connected to the transformer, the TIU, and the track. Now if you look closely, you'll see that all I have done is change the wires so that the track power is now going through the TIU on its way to the track. Now when I turn on the power, the TIU adds the DCS digital command signal to the power. Now, here's an important point that you should know about DCS. You can use any UL-approved transformer with the DCS system. As you can see, I'm using an old Lionel KW here, and if you already have an old transformer that you've been using to run your trains, you can probably use it with DCS. You do not have to use an MTH transformer with DCS. In the DCS instruction book, in Appendix D, is that list of compatible transformers I mentioned. It's a long list because there are only a couple of transformers that are not well suited for use with DCS. You may have a small MTH Z500 or Z750 transformer that came with a train set. If so, MTH makes this adapter cable, so you can even use these transformers to power the DCS system on your railroad. This is MTH part number 50-1017, and it's available from your MTH dealer. We've got our TIU connected between the transformer and the track. I have two MTH Protosound 2 locomotives on the track. Now, when I turn on the power to the track, nothing happens. What's going on here? Why didn't the trains move? They didn't even light up. The lighted lock-on shows I've got power on the track, but nothing's moving. Right from the start, you can see that command control is a little different from conventional mode. These locomotives aren't moving because I haven't told them to move yet. In the command mode, locomotives don't get their instructions from the track voltage like in conventional mode. They get their instructions from this, the DCS remote control. You actually communicate directly with each individual Protosound 2 locomotive on the track, even though they're in the same block on the same track. Look at the LCD screen on the remote. There's one of our locomotives listed right there on the screen. That means it is the active engine. Remember that term, active engine. If I roll the thumb wheel up on the remote, that engine starts to move. This engine is running without sound, which is a feature of the DCS system. You can actually run your engines without the sound systems turned on if you want to. This could be a good idea if you want to run your trains late at night when the rest of the family might be asleep. But we all know that sound adds to the fun. So let's turn on the sound system in this engine. It's very easy. In fact, it's only one button on the remote. All I do is press the number 3 key, which is also labeled Startup, and watch what happens.
Go ahead, 9654. We're ready to go.
The locomotive's sound system starts up, and the lights come on. What about our other locomotive? All I have to do is press ENG to see my list of engines, use the thumb wheel to select the one I want, and press it. Now you can see our other locomotive shows up in the LCD screen as the active engine. Now, if I press Startup, the sound system in this engine starts up. Now, both engines are up and running in the command mode with their sound systems turned on. I have complete and separate control over each individual engine in command mode, even though they're both on the same section of track. I can control their speeds, blow the whistle, ring the bell, and use all the other neat features that are available in the command mode. So, what have we learned? We've learned that in the old conventional mode of operation, we had no way to control engines separately if they're on the same track. The engines all get their instructions from the track, and since they're all on the same track, they all get the same instructions whether we want them to or not. In command mode, we found that we can control each engine separately, even though they're on the same track. And that is the fundamental difference between conventional and command modes of operation. With command control, you run the engines, not the track. When you operate your MTH Protosound 2 locomotives in command mode, there are some additional features available in these locomotives that you can control from the handheld remote. For example, you can turn the smoke on and off from the remote with the push of a button. When you turn the smoke off, it happens almost instantaneously. When you turn it back on, it'll take a moment for the smoke unit to heat up to operating temperature so that there's always a slight delay before you see the smoke start when you turn it on. You can control the volume of the sound system with this button, the 2 and 5 buttons, like this. You can turn the headlight on and off. However, you can only turn the headlight on and off when the locomotive is stopped. You can start the passenger and freight announcement sounds by pushing this button. This feature will be a lot easier to show you when we get out on the layout. That's also true for the Doppler effect button. This is a really neat effect that I'll show you a little later when we get out to the layout. This button, marked Read, is a powerful function. When you press Read, the system searches for all available TIUs and AIUs in the system. It also refreshes the active engine list. If a locomotive has been previously set into the remote and it's on the track, the remote will automatically move it to the active engine list when you push Read. If a programmed locomotive is not on the track, pushing the Read button will automatically move it to the inactive engine list. Now we'll talk a little bit more about the Read button and the active and inactive engine lists a little bit later. Before we go out to the layout, I want to show you some things on the TIU that you should know that we haven't talked about yet. The TIU has to have power in order to work, and it can be powered 2 different ways. It can be powered via the fixed in 1 channel. If you connect a transformer to this channel, as we did here, you're okay. However, there is a better way to power the TIU. You can also power the TIU by plugging a small AC transformer into this plug. Any small transformer that can provide around 18 volts AC at an amp or so will work here. The current draw for the TIU itself is not very high. The power brick from a Z500 or a Z750 is ideal for use here. It's a good idea to power the TIU with a separate power supply for several reasons. Let's say you're running trains using the fixed in 1 channel and you have a derailment that creates a short and trips the breaker in your transformer. If you're powering the TIU via the fixed in 1 connection, the TIU shuts down when the breaker trips because it's no longer getting any voltage from the transformer. If the TIU shuts down, the DCS signal is no longer being put into the track, so you have no control over the other engines that may be running on the layout at that time. In addition, if you're using the variable output channels on the TIU, they shut down. So any trains running on those channels will stop too, whether you want them to or not. In this situation, getting everything reset back to normal can be a real problem. However, if you power the TIU from this jack with a separate small transformer, you will always have control over the layout no matter what happens. If you get a short that trips a breaker in a transformer feeding the fixed in 1 channel, the only thing that happens is the track power to that section of the railroad shuts down. The TIU itself is still running, and you still have control over any trains powered by other TIU channels. Let's take a closer look at the TIU because it has a few features we haven't talked about yet. Notice that it has 4 channels for track power. 2 of them are fixed, 2 of them are variable. Now what does that mean? Let's talk about the fixed channels first. On the fixed channels, whatever voltage you put in here comes out here to go to the track on the output side. The voltage does not change within the TIU. These channels are normally used for command-only operation. However, there is a way to make them variable, and I'll show you how to do that when we get out to the layout. These channels out on the ends are the variable channels. The only difference between the fixed and the variable channels is that on the variable channels, the voltage to the track can be changed inside the TIU using the DCS remote. The DCS command signal is present on all 4 of these outputs. For those of you that are familiar with the Lionel Trainmaster system, the variable channels have the equivalent of a Power Master or a TPC 3000 built into the TIU. That means you can use these channels to vary the track voltage so you can run your conventional locomotives with the DCS remote. It's a way to put the throttle handles of your transformer in the palm of your hand with the DCS remote.